So what's going on, guys? DIY Dan here again, and this is another episode of Day to Day Around the House. In this video, I actually went over to help my father and mother-in-law replace a ceiling fan that had gone bad in their house. During this process, I had actually gotten shocked because of some bad wiring that was done on the installation of a Gfci outlet in their master bathroom. I'm going to show you that bad wiring that was done, what I did to correct this problem, and the addition of a new Gfci outlet in their master bathroom, including some wiring diagrams because it's easier to explain on those than it is on the actual wiring in the house. And on those diagrams, I'm going to explain a couple different ways that your house might be wired and a couple different ways to wire your outlet in depending on what you want to do. So here is a chapter index of what takes place in this video and at what time it happens. So if you don't need to watch the whole thing, you can bypass what you don't need to see, so I don't waste your time. And let's get to it. So a quick story on why I ended up adding this outlet in my father-in-law's house in his bathroom. We were actually helping them replace a ceiling fan that had gone bad, and I usually just shut off the light switches that are powering that ceiling fan, and that's what I did here. I removed the fan and I was getting ready to install the new one when I got a little tickle, and then I tried messing with it again and I got more than a little tickle. I got shocked.
You okay? It's off. Oh no. You okay?
So I ended up getting my voltmeter and I am going from the common to a ground. And I've got 98 volts there, which definitely should not be there. Now, if I would have been more on the safer side, I should have probably shut the breaker off. But if I had shut the breaker off powering that ceiling fan, then I wouldn't have found this problem. So there is good and bad to this situation. Now, luckily enough, my father and mother-in-law were able to give me a good idea of where the problem was because they had an extra outlet installed in their bathroom and they weren't very confident in the way it was done, so that's the first place I went. Now I did shut the breaker off and then I pulled these covers off. I tested my voltage to make sure there was nothing there, and then I took it apart a little further. And what I found was definitely the problem. So all outlets that are in a bathroom have to be GFI protected. This was an actual GFI outlet, so there wasn't a problem there. However, there was a problem with the way it was wired. The light switch that they had pulled power off of only had a hot in and a hot out that was going up to the light in the bathroom, and then it had a ground. So to power this GFI outlet, they pulled off of the hot that was going into that light switch that had power all the time, and then just pulled another ground from the case of that light switch box. Now I did do some research, and you can use a hot lead and a neutral on a GFI as long as you label the outside of the outlet that it is not grounded. However, this one was not labeled, and furthermore, the hot was going to the common pole on this outlet and the ground was going to the hot. Irregardless, I didn't feel this was the safe way to go, and that's when I decided to wire in another outlet in this bathroom. So I disconnected both of those wires from that GFCI outlet, removed them from the light switch box, went ahead and put my plastic box back in the wall and put a cover plate on that. The wire connections on the light switch didn't look too good either, so I disconnected those, cut them back just a little bit more, stripped them back, and reconnected those to the light switch, and then went ahead and put the cover plate back over that. After disconnecting those wires, I did check my voltage going up to that ground in the ceiling fan, and I no longer had that 97 volts. So because there was no neutral in that light switch, and I knew there was power going up to the light, that's what I took down next to see what was going on in there, because I figured they were running power to and from the actual light to that switch. So right here I made my first mistake for this project, and I always tell you the mistakes I make. Once taking the screws out that were holding this light fixture in place, I did notice that they had painted the walls and they didn't take the light fixture down. They just painted around it, and I should have taken a razor knife and cut around the light fixture. And because I didn't do that, I ended up peeling some of the paint off the wall. There was 2 screws that held the light fixture to an adapter plate, and then there was 2 more screws that held that adapter plate to the light fixture box that was mounted in the wall. So in this wiring box, I did find a neutral, a hot lead, and a ground, so I had what I needed to run a new GFCI outlet. Once I verified that, I took out the 4 screws that were holding the medicine cabinet to the wall and removed it. Once the medicine cabinet was out, I measured the length and the height of that medicine cabinet. I also measured the length and height of the opening that was cut out and boxed in for the frame of that medicine cabinet. And I had an inch gap from top to bottom and an inch gap from side to side. And that was going to give me enough space to run the wiring from the light fixture down along top of the medicine cabinet, down the side of the medicine cabinet, and down to the new outlet box. Using a density stud finder, I marked out and verified the location of the studs underneath the medicine cabinet because that's where I was going to put the new outlet. Then drilled a hole so I could cut out the drywall for the new outlet box. I also drilled a hole in the corner of the opening down through the 2x4 so I could run the wiring down to that outlet box. I put the outlet box that I intended on using against the wall and marked out the outer diameter of it. When purchasing an outlet box, I like to get the deepest ones possible because it makes it easier to run the wiring, and I also get the ones that have the flip out tabs to hold in the drywall, because even if you're just planning on running a couple screws through that outlet box into the 2x4, it just adds extra strength to the holding power of that box. I try and get my teenage kids involved in these projects as much as possible, so hopefully I don't get quite as many phone calls when they get a place of their own and want to do something like this. So right here I'm having them cut out the hole for that outlet box. It is critical to check where your 2x4s are in the wall before drilling any holes, so you don't get on the wrong side of one of those 2x4s and not be able to run your wiring where you want it to go. So I went ahead and verified where the 2x4 was that light fixture mount was mounted to, and then drilled a hole on the other side of that 2x4 so I could reach my wiring to the light fixture. I bought 25 feet of 14 gauge 2-wire with a ground Romex cable for this. Ran it through the pre-existing hole in the light fixture box down through the hole I made through the 2x4 so I could hook the wiring up in the light fixture outlet box. Usually, if you put a little bit of a slit in the outer protective layer on that Romex wire, you can grab the two wires and pull them apart, and it will pull back that protective layer as far as you want. Once I peeled that back, I cut off the rest of that excess insulation off of the Romex. So I'm going to explain the wiring that was done on a diagram here before showing you the actual wiring I did in the house itself, because it's going to be a little easier to understand. Right here is my 120 leg, my common or neutral, and my ground coming from the breaker panel in the house down to that light fixture. So what they did here, because they ran the main powers from the breaker panel to the light fixture instead of to the light switch box first, is they did use the black wire for the hot coming down and powering the switch. Then they used the white wire off of the 2-wire Romex as the hot returning and powering the light fixture. And then they went ahead and took the ground and grounded it to the box in the wall that was holding the switch because it was a metal box. So when they had whoever hook up this outlet off of what was in this light switch box, they never had a common to correctly hook up. And not to mention, they actually had the hot wire going to the common, the ground going to the hot. So that's why we just eliminated this. Basically put this back the way it was, and now we're going to get into how I wired the GFCI off of the wiring that was supplied in the light fixture box itself. Okay, so basically when we added this GFCI, I'm just coming off of each one of the wires that are coming from the breaker panel itself. We're going to pull off the hot coming from the panel, the common coming off the panel, and the ground coming off the panel. So right here, I'm going to go over the hot first. Hot, this is where it teed off and went over to the switch. So we're going to pull that wire nut off here. We're going to take it over to the line side of the GFCI. That's absolutely critical. You do not want it on the load side, otherwise the GFCI will not trip properly. So make sure you bring those wires in on the line side of this GFCI. So we're going to hook that one up to the line side hot. The common, we're going to come off where it teed off and went down to the light fixture. We're going to come off of that, and we're going to come down to the line side white connection. And then the ground, where everything was pigtailed together there, we're going to bring that down and go over to the ground stud on the outlet. If you're running any outlets after this GFCI and you want all those outlets to be protected, when you hook those outlets up you would put them on the load side of the GFCI. In case you wanted this outlet to work when you triggered this light switch on, we would remove where we had it powered from this point here, and all we would do is come in and hook it up where the power coming from the light switch was going to the light fixture. So we would tee it off there instead of coming off before the light switch. And that way, this outlet's going to be dead unless you turn the light switch on, then it's going to be powered. So real quick, I'm going to go over some other ways your house might be wired or some other ways you can wire in your outlet depending on what you want to accomplish. In this diagram, I've actually got the power, common, and ground coming into the light switch from the panel instead of into the light fixture. If this is the case in your house, you're going to have your power, common, and ground. The power is going to go into the light switch, come out of the light switch, go up to the light fixture, and then they're going to tee off of the ground and neutral and come up there as well. In this case, you would do the same thing, just tee off of each one of those wires and go down to the line side of your GFCI outlet. The only difference is with the wiring set up like this, the only time you're going to get power to this outlet is with the light switch in the on position. So if you've got your common power and ground coming in from the panel to the light switch, and you just want to mount an outlet right next to that switch or right below it, kind of like what they did improperly to begin with that I went and covered back up and then changed. However, since the power, ground, and common are coming in from the panel to that light switch, we do have what we need. And once again, all we would do is tee off of each one of those and go to the line side of the outlet. So that might come in handy wiring that in like that. If, let's say, you don't have this outlet right here, what you would do is take this cover off, remove the wiring from this light switch, pull it off. You can go in and cut the nails with a hacksaw blade or whatever and take out this 1 gang box here, cut the drywall out a little bit more this way, and put a 2 gang box and just add an outlet right next to your actual light switch. So here is a GFCI outlet, and I'm just going to go over the connection points on this real quick. And on the back of this, you can actually see it says line, and that is where we would hook up the power that's feeding to this outlet. You can notice this one is taped off, and that's because you don't want to use these unless you are protecting other outlets with this GFCI outlet. So right here, I'm going to untape this so you can actually see that. So you can see that one says load, and they're also labeled white, which are the silver bolts on the outlet. And that goes for any outlet actually. Where the neutral or common or white wire goes is going to be the silver bolts, and the hot side is going to have the gold colored bolts on it, which is where your black wires would go, and then your bare wire or your green wire is going to go to the grounding stud at the bottom of the outlet. These outlets can vary a little bit. Right here, the cinch locations are actually right here, and they go underneath that plate. So when you tighten that bolt down, it cinches the plate over the top of those wires. Or if you choose, you can do the hook and go around the outside of the bolt and tighten it down. So right here, I'm just hooking up the common. I cut the wire nut off and stripped back those wires a little bit more, and then added the white wire from my new Romex cable to those 3 wires and putting the wire nut back on that. When you're putting these wire nuts on, make sure that you strip that wiring back enough where you're not tightening the wire nut down on any of the insulation, but make sure you don't strip it too far back where you've got bare wires hanging out past that wire nut. Usually, if you can have some good hand strength, you can just do those by hand and twist them as tight as you can by hand. You might want to take a pair of pliers and give them a little bit extra if you don't have too much hand strength. And then I always tape up my connections afterwards for an added layer of protection. And since I was in there, I went ahead and taped up any of the wire nut connections that were previously made, even if I didn't touch them. So now that the common's done, I'm going to go ahead and hook up my hot wire. So I'm stripping that back right now. So a couple other things to watch out for if you are using wire nuts. You don't want to get too small of one where not all of the wires are actually pushing up in to that wire nut, obviously. You also don't want too big of a wire nut where you cannot firmly tighten it down. So if you have a proper size wire nut, you should not be able to keep turning it by hand. It should basically stop you. If you can keep turning it by hand and it doesn't tighten down, then it is too loose. And if you have too loose of a wire connection, that could create heat and a possible fire hazard. You'll notice that I used a yellow wire nut on the common because I had 4 wires going to it. However, the hot leg in this light fixture box, I think there was 5 wires and I had to use a bigger size wire nut so I could get all of those started in there correctly. You also want to make sure that all of your wires are at equal lengths when entering the wire nut. You don't want some that are longer than others because then again you could create a loose connection on the wire that's shorter because it's not pulling into that wire nut at the same time as the other wires, and therefore is not getting tightened down as much as the other wires, which again could create a loose connection on that wire, and loose connections can create heat and a possible fire hazard. So here's a good example of why I like to buy as deep of light fixture boxes or outlet boxes as possible. This light fixture box was pretty full already, and now I've added another set of wires to it. So I did struggle to get all these wires pushed back into that outlet box so I could put this light fixture back on. Now obviously there could be restrictions in the size of box you can use depending on the application, but it's just something to keep in mind. Now I did forget to hit record when I put the other screw in this light fixture and put the other bulb in and the cover back on, but I think you get the idea as far as that goes. Now we're going to get to wiring in the actual outlet underneath the medicine cabinet. I fed my Romex wire through the hole I drilled through the bottom 2x4 and down where I cut the hole for the outlet. Stripped back the outer protective layer on the Romex wire. When putting the wires through the electrical outlet box, you only want to break one side of the tab where the wires go through, because that other tab will actually help hold those wires in the electrical box. If you break the entire tab off, those wires are just free floating in the outlet box. Stripped back the insulation on the hot and common wires. Used a pair of needle nose to bend my ground wire at a hook and then put it on the ground stud on the new outlet. Make sure you put the hooks around the bolts in a clockwise manner. If you put them on in a counterclockwise manner, there's a more likely chance that they're going to spread out that hook as you tighten it down. You could also use a hook to hook up the common and hot wires if you choose. However, I decided to put the wires in through the hole in the back and then tighten the bolt down because that is a cinch and still a very good connection. There are certain outlets that when you push those wires in through the back of them, it is just a spring that holds those pretty much, and that I would never use because that could create heat and a possible fire hazard. After hooking the ground up to the grounding stud on the outlet and the hot and common wires up to the line side of that GFCI, I went ahead and pushed my electrical outlet box into the wall. Right here you can see as you tighten that screw down, it flips that tab out and holds it against the drywall. Make sure when you're tightening that screw down at first, it should be completely loose for a quarter turn. If it's less than that, then you might be spreading it into where you cut out the hole for the drywall and not behind it. Once tightening down those 2 screws in the outlet box and securing it, I went ahead and put the outlet in place and put the 2 screws that hold the outlet into the outlet box and tightened those down. Then went ahead and attached the cover plate. Then went and turned the breaker back on. Double checked that I made sure I had power at that outlet at the correct places. So you want to go from the ground to the hot and then from the common to the hot, and you should have 120 volts, give or take a little bit at both of those locations. And then for kicks, since I had that previous problem, I did check from the ground to the common to make sure I didn't have any voltage there. However, if I did have voltage there, that GFCI should have tripped. And then I went ahead and tested the GFCI and made sure that I dropped the power and then reset it and checked to make sure that I had power again. Then there's several different ways you can hold that wiring to the 2x4s on the inside of that frame. Just some simple U-shaped nails like this will work. Just make sure you don't hit them in so hard that you puncture through the protective coating on the Romex. And then once I secured that All I did was put the medicine cabinet back in place. Make sure you secure that Romex next to that 2x4 away from where the screws that hold the medicine cabinet in place are, so you don't puncture through your wire as you put your medicine cabinet back in. And that's all there is to it, guys. Hopefully you enjoyed this video and it gave you some good information. If so, make sure you hit that like button and subscribe if you haven't already. I'd really appreciate it. The whole concept of my channel is to give you guys the most information in the least amount of time as possible so I don't waste your time. And I hope to see you next time. Have a good one. Later.